Okay, for these problems, all you really want to do is just select random values for x and y, and then just test them out, see whether or not the statements hold true. And if you can show that for one set of x and y values it's not true, then you're essentially saying that the equation isn't true. All right, so let's have a go. The easiest one to start off with is x equals 0 and then y equals 0. And we can see that straight away that at least one of those equations is not going to hold true for those two values. So I'm going to just draw out a table for that, just to show you the progress that I'm making as I'm working my way through these combinations of values. So x equals y and x equals 0 and y equals 0 I'm going to start off with. Okay, so x equals 0, y equals 0. The left-hand side of that equation is going to be a sine of x plus y, which is going to be sine of 0 plus 0, which is sine of 0. So sine of 0, we don't need a calculator for that. We know that sine of 0 is 0. All right, so the left-hand side is 0. The right-hand side, sine of 0, sine of x, which is sine of 0, and sine of y, which is also sine of 0, is still going to be 0. All right, so we haven't disproven the equation. We've shown that it is true for one value, one set of values. What if we were to choose another pair? Say, for example, we chose 45 degrees. Right, so 45 degrees, 45 degrees. We'll just keep it simple. We'll pick values where we don't really need to use a calculator to work out the values of those trig functions. So we can do these in our heads. So sine of x plus y is going to be the sine of 90 degrees. We know what that is. Sine of 90 degrees is 1. Yep. The right-hand side is going to be sine of 45 degrees plus the sine of 45 degrees. Right? And we know what those are as well. We remember our work on those special triangles, and the sine of 45 degrees is 1 over root 2. So we've got two of those, which will obviously not equal 1. Yep. So if you wanted to work that out, you'd have 2 over root 2. Okay, so we've gotten to the point now where I say, well, that equation cannot be true. Sine x plus y is equal to sine x plus sine y, because it doesn't hold true for that pair of values for x and y, 45 degrees and 45 degrees. So can't be true. We do the same thing for our cosine equation. So that's sort of that's equation 1. This is equation 2. We do the zero zeros, just like we did for that first problem. We find that the left-hand side, which is the cosine of 0 plus 0, which is going to be cosine of 0, that, if we remember right, that's 1. And then we've got the cosine of the sum of those two, so cosine of 0 plus the cosine of 0. And that's going to be equal to 1 plus 1. Each of those is 1, which is 2. And those two values are obviously not the same, so therefore that is not true either. All right, so that second equation isn't true. And then the last one is with tangents. So let's just see if we can disprove that last one with zeros as well. So 0, 0, and then we've got tangent of 0, and that's equal to 0, and tangent of 0 plus tangent of 0. Well, that's not going to work. So that's still 0. So that's true for that. What if we did the 45 degree stuff? So 45 degrees for x and y. So that gives us tangent of 90 degrees. Now we know that tangent of 90 degrees is infinity, doesn't exist. But we know that tangent of 45 degrees does exist. All right, so if we were to individually work those out, tangent of 45 degrees is in fact 1, so that's going to be 1 plus 1, which is 2, and 2 is not undefined, 2 is very clearly defined, so therefore that third equation isn't true either. Right, so none of those equations are true. You can't split the argument of the sine, cosine, and tangent into 2 separate sine, cosine, and tangent sums. Right, so this leads on to today's work, which is about what do we do when we've got the sine of 2 things inside the argument for that trig function, or the cosine of that. Alright, and that's going to be given by those complicated things.